Okay, let's review what we talked about last Wednesday for that 1 hour. We started talking about if statements, and if statements allow us to make decisions. C# uses two tools to make decisions: if statements that we're going to cover today and case statements that we'll cover a little bit later. That's for the code behind the scenes, and most languages provide the same kinds of tools. Generically, they're called case statements, but the syntax in C# they're called switches. Just a little weird if you ask me, but that's the terminology. In VB, it was select. So the generic term is case statements for multiple choice. We'll see that a little bit later. On the form, we can have checkboxes and radio buttons. That's probably going to be Wednesday before we hit those. If statements come in three flavors. A simple if, where we ask a question if the condition is true. Remember, the condition always has to be a true-false statement. If the condition is true, we do something, otherwise we skip it. It's called a simple if. Remember, the do nothing should always be a false, otherwise in pseudocode it doesn't look very good. In pseudocode we use the keyword if. You can capitalize it all caps if you wish, and an end if, and the contents are indented to show that this is the true part of a simple if. Notice that take a walk is not part of the if. I've said this a couple of times, I'll say it again. If we could take a walk here and take a walk there. Now it's redundant, it's in both. If I put it on this side and that side, if it's on both sides of the if, there's a pretty good chance you can remove it because it's redundant. So you find yourself typing or copying and pasting the same command on the if and in the else. Take it out, probably, or ask for help because it probably can be removed. A regular if-else, these are the most common types of ifs where you ask a question. If the condition is true, you do one thing. If it's false, you do something else. They don't have to balance by any stretch of the imagination. What you put on either side of the if statement can be anything. Here it's display statements. It could be input. It can be calculations. It could be other if statements. All of your ifs come back together to an end if. Here's a bad example of redundant code: eat supper, eat supper. Eat supper is on the true part and in the false part. Notice in pseudocode, if, else, end if, they all line up. The true stuff is right here, very easy to see. The false stuff is right here, very easy to see. Go to bed is on both sides. It doesn't belong inside the if, it belongs above and below. Where it goes, I don't have a straight answer for you. You have to think logically. What do I do first? Go to bed, do this stuff, eat supper. Well, we're going to eat, then study, then go to bed. But again, if you find yourself typing the redundant code, stop, think, can I remove it? And if the answer is I don't know, then ask for some help. If I find redundant code, I'm not supposed to mark it wrong, but sometimes I just can't help myself. It's all right, you get updates. Fix it on the update. Normally I will tell you have redundant code simplify. You can also use else ifs. An else if asks multiple versions of basically the same question. What color is the traffic light? If it's red, do this, and then get out. If it's not red, then ask this question. Is it green? If it is, do this, and get out. Otherwise, it must be yellow, so do this, and then get out. Else if generally asks the same question with different parameters like red or green. We looked at an example in the book where we looked at somebody's test score. If it's greater than 90, they get an A. If it's greater than 80, they get a B. That was all else ifs, and we saw the author's version of this with the diamonds going sideways. Much harder to understand. Remember that? Yes? Sort of. Yep. Thanks, Tim. Can hear you nodding all the way over here. Okay. That was in page 218. So those are the different kinds of ifs. There's also nested ifs, which are ifs inside of ifs. And again, the indentation critical. Here's what you do if it's true. Here's what you do if it's false. But the false part is that it's only if. And if this if is true, here's what you do. The indentation is critical. Visual Studio will do it for you most of the time, but if it messes it up or you hit the backspace key or you copy and paste and it doesn't indent right, it is your job to fix it. Anybody found in Visual Studio will fix it for you if you ask it. Or I should say tell it. Anybody found that yet? Not yet. All right, I'm going to go look for it while you do this little exercise. It's your chance to do a little design here of a decision process. We're at the store, and your iPhone or your Galaxy whatever has an app on it now that helps you decide whether or not you should purchase something that you're looking at. It's your compulsive buying app that stops you from being compulsive. What I would like you to do is in your groups, wherever you are, and Kai, you come over here and join Sean, the rest of you got at least 2 groups, get together and in a Word document, in a Notepad document, or in Visio, whatever you choose, design this that tells you that this app that determines whether or not you should buy a large screen TV. Draw a flowchart to determine if you should buy a TV. First thing you have to do is get some stuff. What inputs do you need? You don't have to draw me a screen, just imagine the screen and tell me what process you would go through. It's similar to this, but the first one's not as complicated. You either have the money or you don't. How do you know? So put your heads together, give you 2 or 3 minutes. In the meantime, I'll find out how to get Visual Studio to clean up my bad indentation. Okay, before I turn the recording on, we drew some boxes, so we have to get the savings balance because we need that information to make a decision. We need the price of the object that we want to buy, in this case a TV. And then we decided that we're going to ask if the savings balance, if the money I have, and you can make that checking or whatever, just not credit cards yet because that's coming next, is greater than or equal to the price. What was your question, Kai?
Would you have to put if in front of that, or is that?
You can put if in front of it, but it's a diamond, so it's a decision. Okay. Right? If you put if in there, absolutely not wrong. So this now has a true and a false part. And somebody in the other class said, well, how do you know which side to do first? Or I try to get my head around the true part and the false part, and I just get all, well, just do one side at a time. If the savings balance is greater than or equal to the price, then I'm going to display, which is an output. And display here is generic. I could put that in a label as well. What do I buy? Do I buy it or do I leave it? Buy it. Exclamation mark. Buy it. Okay. And what else? That's it. That's all my app needs to do, is display this message. It's trying to help me decide whether I should buy it or not. It's telling me if my savings balance is greater than or equal to the price to buy it. This little guy here, that greater than or equal to, it's called a relational operator. Many people have trouble keeping the arrow left versus arrow right straight, and there's 600 different ways of little tips to help you remember that, and after a while you just remember. Okay. This is greater than or equal to. The wide part points to the big thing, savings greater than the price. Okay. However you remember, it's fine. There's a list in my notes. We'll talk about them next. These then need to be connected. I'll take care of that in a minute. But what if, so that's it. I'm done with that side. So now we should do the false side. Now we should connect. My connecting tool, go back home, because these are kind of going around corners. Hey. And then we should label it. There, now that one's done. Now what about the other side? Well, in that case, we only do one more thing, same type of stuff. Looks like I got the connector as well, which might be handy. If I can get hold of it, got it. Oh. And now we basically say walk away. But in order for this to work, we need some input. If statements don't generally happen, they need something from somewhere. Sometimes it's the time of day. Ever notice when you log into Google, it checks the weather first before it puts the background on your Gmail site? It knows what the weather is. It gives you clouds or sun or, heaven forbid, snow, but it's coming. Right. How do they do that? They look at your weather report somehow and get that input and make a decision of what picture to display in your background. Everything is done with decisions, and just about every decision requires at least some kind of input. Then remember, all if statements come together. Just type an end if in here and connect those as well. And then I'm done. Well, what if I want to check a different TV? Well, then we start the app over again. You enter the price of the next TV and it looks up your savings balance and it says walk away or buy it. And you can just do this over and over and over again until you finally walk out of the store with a candy bar. Right. But that's the purpose of a decision, is to help us. Notice only one of these things is going to be displayed. There's no way to say walk away after you buy it, or walk away and buy it, or you can't do it. Doesn't make sense. Okay, that's a little simplistic. So now let's take it to a different level. I'll give you a little more time. Now let's add your credit card to it. And what I want to know from you is, should I pay cash for it? Should I charge it? Or should I mix them? Those are the three answers. Cash, charge, or mix it. You will need more inputs. So modify your flowchart to give you more options for walking before you walk away from this. And that's the fourth option, by the way, is walk away. It's still there. That's the fourth option. So now modify your flowchart so that it can deal with that. So what's different is a little bit how we process here when it's true, but if it's false now, we're not giving up. We're going to look at some other options. So first of all, let's take care of this true side. Instead of just saying buy it, let's say buy it, and I'll say with cash, though that could be from savings or whatever you want. Because if the savings balance is less than the price, I'm going to buy it with cash. And at least in my case, that would be my preference. Now, maybe in your case, you'd prefer to use your credit card, your Best Buy card to get your bonus points and then pay it off later. That's a different problem. Here, I'm going to pay cash if I can. Now, I'm going to run out of room here, so I'm going to make a little more room. Because over here, things are different. I can't just, this walk away, I'm going to need it, but I can't just walk away. I'm not giving up yet. So what do I do now? Okay, now I want to know if my credit balance, wait a minute. Credit balance? Limit minus the balance, okay? Because I don't want to know how much I've charged. I want to know how much room do I have. So I could calculate that separately first, but I want to show you that you can do it inside of the if statement. I'm probably going to have to make this significantly bigger, because now what I want to know is my credit limit minus the credit balance greater than or equal to the price? Well, wait a minute. Order of precedence. What happens first? Coming up in our notes. All relational operators, that's a greater than or equal to sign. All relational operators, there's 6 of them, are all at the same level, and they all happen after math. So this happens first. It calculates the room that we have on our credit card and says, is that bigger than the price? If it is, then we say charge it, or whatever message you have here. Get my connectors going here. This one's done, and this one's going to need an end if now. That may be down here a ways. Whew, that didn't work out the way I wanted to. So we'll save that. Now, what if the credit minus the balance is greater than or equal, is not greater than or equal to the price? Well, then we might still be able to mix it up by adding my savings to that. Okay, so now I need another question. And my flow chart's getting nice and wide. That's okay. I can fix all this later after I get it laid out. Now I can put in here even more. Let's add to that the savings balance. Please, there it is. Order of precedence doesn't make any difference because subtraction, this subtracts, I'm sorry, it does make a difference. This subtracts, calculates my credit card limit. And then I add to that my savings. If I combine my savings with the credit card, have I got enough to buy this thing? If so, then I want to say something else like clean out savings and charge the rest. Otherwise, what? We could go crazy, right? And go call my friend and say, you got 20 bucks you can loan me, or I need $375. What do you get? No, we're done. Walk away. So there's my walk away. So once again, now we got to connect these things, and that can sometimes be the hard part. This is a true over here. And if it's true, then we charge it. Otherwise, we ask another question, then there's a true over here and a true over there that can't go through the A, so now I got all kinds of issues. That's gross. There, much better. Now every one of these is a separate if. Could we have written these as else ifs? We could have, because it's basically the same question. Do I buy it or don't I? Do I have enough of this? So maybe if I were making these else ifs, then these would go underneath. But I want to do both so that you can see how you have to lay these things out and where the end ifs go and so on. Every one of these is its own if. So this end if belongs to that if up there. This end if belongs to that if up there. And finally this one, I got two of them, belongs to that one. Every if you're not doing else ifs, every if gets its own end if. So once again, connect. So it's kind of in the way. Then this end if connects with that because it's the false part of that if up there. And this is the false part's one big, huge, ugly false, right? Can't pay cash. And then underneath here, somewhere I probably lost my end, but it's floating in the neighborhood somewhere. Every if gets its own end if. The only exception to that is else ifs. So let me see how quickly I can duplicate this and do else ifs. Might be a little more tricky than I want it to be.
Would you just connect the last one to the end button? Like just whatever one you want?
Yeah, wherever the end went, it's floating around in there someplace. Still got too much stuff. I'm going to steal my diamonds and I'm going to stack them. And then I'm going to steal my results and I'm going to stack those. And I promise to zoom in on that so we can read it when we're done. But remember, this is the else if version. Okay, and we still come in the top here with the A, so I guess I could steal, time to zoom in a little bit here. I can steal these two things and copy, paste, But now the connection looks a little bit better. And actually, I can probably just use the hover technique here and connect these to some extent. Come on. This one isn't going to work, but this one might. It's been too far away. And now I need one end if, because this is an else if. An else if only has one end if. And now all of these connect to that. And if you do this right, the connectors will join. Which one do you like better? I'll take this one. In this example, I'll take that one. But you can't count on every example being an else if. So I wanted to show you both, and I will save this and throw it in the Unit 5 folder as a completed one so that you can see them. It's not complete. Maybe while you're doing the next exercise, I'll complete it because each one of these true paths needs to be labeled. And each one of the false paths needs to be labeled. But here, all the trues go sideways, the falses go down. Over here, we get this waterfall effect, and this is false, 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 all the way over true, true. And I can clean this up so it looks a little bit better. But you get the idea. Either one of those will work. When we come back from break, I'm going to code them. And then after I'm done coding them, remind me to stop the recording. Actually, I'll stop it now and then pick it up from there. So take 10, come back, and I'll have this for you saved.